welcome to your lesson on exact values on the unit circle. Let's begin here. To talk about exact values, we have to talk about something called the special right triangles. There are infinite kinds of right triangles, but which are considered the two most special right triangles? What do you think? Well, it happens to be this one and this one. So the 30, 60, 90 right triangle and the 45, 45, 90 right triangle are considered special right triangles. Let's take a look at some properties of these triangles. So you are special, and also you are a special right triangle. Now I'm talking to these triangles. Okay, so there they are, our two special right triangles. Let's take a look. Beginning with the 45, 45, 90 right triangle. Let's say we have a 45, 45, 90 triangle. Looks like this. I made it sit like this so we can see clearly it's isosceles. When these two base angles are the same, these two sides will be the same. So if we have one here, we have one here. Now, what is the length of this side? We can use Pythagorean theorem to find that length. And simply 1 squared plus 1 squared equals hypotenuse squared, c squared. So that is 2 equals c squared. And that means c squared, sorry, that's c equals the square root of 2. So we just found out that this side here must be root of 2. So when we have a 45, 45, 90 triangle, that side can be called 1, 1, and root 2. Of course, this triangle can grow in size, but these sides will stay in the same proportion. For example, if this was 2, then this would be 2, and then this would be 2 root 2. So this is the basic 45, 45, 90 triangle. When working in a unit circle, however, because we're going to bring these to the unit circle, we know that the hypotenuse is 1 because the radius of a unit circle has a unit length of 1. So if we change this to a 1, it means we have to take that and divide it by root 2. So if that became 1 there, then we would have to 1 over root 2 for each of these sides, right? Because we divided this by root 2 to get this. So now we have to divide each of these sides by root 2. So 1 over root 2 can be rewritten, however, as root 2 over 2. Because we know there's a kind of a general rule in math. We cannot have a root in the denominator. So to rationalize that denominator, we will multiply top and bottom by root 2. So we end up with root 2 over 2. So that means these sides are root 2 over 2, and that is the same as this triangle, except for we've made the hypotenuse into 1. Now you need to memorize this. We'll talk about that in a minute, but you need to remember always that we have root 2 over 2 and root 2 over 2. Let's switch now to the 30, 60, 90 triangle, and let's begin with this equilateral triangle 60, 60, 60. Well, that's not 30, 60, 90. How do we make this into 30, 60, 90? To do that, oh, by the way, we also called the sides 2, so we said they're all equal sides of length 2. So to make it a 30, 60, 90, I can drop a perpendicular down like that, a height line. Now we have a 90-degree angles here, and that top angle has been bisected into 30 and 30. So we can see clearly now we have a 30, 60, 90 triangle. And since that side on the bottom has been bisected, we have 1 and 1 here. So in that triangle, ignore half of it, and we have a 30, 60, 90. This 30, 60, 90 triangle has a hypotenuse of 2, this length of 1, and then how long is AD? Well, to find AD, we can use Pythagorean theorem as well. We can say 1 squared plus AD squared equals 2 squared. Now solving this for AD, we can say 1 plus AD squared equals 4. That means AD squared equals 3 when we subtract the 1. And finally, AD equals the square root of 3. So that means this length here is the square root of 3. But again, just like with the 45, 45, 90 triangle, we want to think about this one sitting inside a unit circle. That means this hypotenuse would have to turn into a 1. So that means every side here has to be divided by 2. So we can do that. Here's the one we just had, 30, 60, 90, with a hypotenuse of 2. Now I'm going to divide the hypotenuse by 2 and make it 1. And also divide both of these by 2, because I'm shrinking the whole triangle proportionately. That becomes 1/2, that becomes root 3 over 2. So now this is the 30, 60, 90 triangle that we could find within a unit circle, because the radius, or the hypotenuse here, is 1. We're going to have to memorize this one as well. So memorize them. Take a moment now, pause, draw them. If you haven't written anything in your notebook yet, draw these. You must remember these always. So we have our two special right triangles. With a hypotenuse of 1, means they can sit in a unit circle with radius of 1. In a 45, 45, 90, we're always going to have root 2 over 2 and root 2 over 2. In a 30, 60, 90, one way to remember these is across from the small angle is the shortest side, and the shortest of these three sides is 1/2, so that goes here. Across from the bigger angle, 60, here across from it we have the bigger side, root 3 over 2. And 1 is actually the longest, because hypotenuse is always longest. So 1 is the longest, root 3 over 2 would be like, I don't know, 1.7 or something, I don't know. But anyway, 1 is the longest, shortest one here, and then this one across from 60. Okay, hopefully you're done memorizing. Now let's look at how these sit in a unit circle, because that's what this lesson is all about, finding exact values in a unit circle. So let's say we spin an angle, and it is 45 degrees. We can draw that, connecting to that point there, drop a perpendicular, and now the question is, well, if this is 45 degrees, how long is that? How long is that? Or what are the coordinates of this point? Well, we just know, we just learned that, well, first of all, this is 45, 45, 90, so it's definitely one of the two triangles we just looked at, and we just learned those are the sides. So that means in this triangle, we know that the y value must be root 2 over 2, because that length is root 2 over 2, and the x value must also be root 2 over 2. So that coordinate, that point, is located at root 2 over 2, comma, root 2 over 2, because those are the x and y values. Pretty easy to remember. Okay, let's look at another one. Let's say you spin an angle, and it is a 60-degree angle. So now you go like this, then you drop your perpendicular, you have 60 here, you have 90 here, so that angle must be 30. So we definitely have a 30, 60, 90. So again, the question is, how long is this? How long is this? In other words, what are the coordinates of this point? So there's our 30, 60, 90. It's kind of turned the other way than this, but you should be able to see what's what. So what is your y value? Root 3 over 2, your x value, 1/2. Okay, both are positive. Remember the positive negative thing, because we have a positive x value, positive y value. Both are positive. Okay, so that coordinate of that point is 1/2 and root 3 over 2. Next, we spin an angle. It is 30 degrees. Draw that line, drop the perpendicular. What will be this coordinate? Try it now. Okay, that's 60. Therefore, we're looking at 30, 60, 90 again. Remember, across from 30, we always have a half. So this is a half. Across from 60, we always have root 3 over 2. So our coordinate must be this coordinate here. Okay, spin an angle. It is now bigger than 90. It goes into quadrant 2, 120 degrees. Draw the line, drop the perpendicular, and think about what triangle you have here. What will be the coordinates of this point? Try it. Okay, that's 60. Must be to make 180. If that's 60 and this is 90, this is 30. We have 30, 60, 90. Thinking of that triangle, looking across from 30, we have half. But this time negative a half, because this is now in the second quadrant and x values here are negative, so we have a negative 1/2 here. But this distance remains positive because the y value is positive, you can see, root 3 over 2. So our coordinate must be this point, negative x value, positive y value, but the same half and root 3 over 2. Great, couple more. Spin an angle, it's a big one, 225. What is the coordinate of this point going to be? Okay, you can do it. Drop a perpendicular. This angle must be 45 because we have 180 and then 45 more to get 225. Now that is a 45, 45, 90. Looking at this triangle, we know these sides must be identical, but both are negative because we have negative x value, negative y value. Therefore, the coordinate of that point is this negative, both negative values for x and y. Great. How about here? Spin a very big angle, 330 degrees. We end up here. What are the coordinates of this point? Check your work, drop the perpendicular. That must be 30 to make 360. This must be 60 then. Across from the 30, 60, 90. Therefore, across from the 30, negative a half. Across from the 60, root 3 over 2. This is positive x value. This is a negative y value. That's why we see negative. And therefore, our coordinate is this coordinate here. Okay, to recap, we can find a point, and these are called exact values, right? We're not having to calculate sine or cosine at all. We know because the angles are all 30, 60, 45, that kind of thing, we can always find the exact values like this without using our calculator. We can recap here by saying the sine of that will be the y value right here. the cosine of this angle will be the x value right here. So that x value is here from cosine. And we didn't look at tangent yet, so it's important to talk about tangent. Tangent can be found by taking sine over cosine. We learned that about tangent. So if you know your sine value and your cosine value, your y and your x, so think of it as dividing y by x. Divide those, and notice we get root 3. So the tangent of that angle is that, root 3, because the 2's cancel. Okay, and we know that angle must be 60, because we can see across from this angle we have root 3 over 2, so it must have been 60, and this must have been 30. Great, one more like that. We have a point here, it's negative x value in this case. Sine of that one is the y value right here. Cosine of that angle is the x value, that negative x value. And tangent in this case, so check this out, the tangent is root 2 over 2 divided by negative root 2 over 2, y divided by x, which gives us negative 1. Anytime you see a tangent value that's negative 1 or positive 1, you know you're working with a 45-degree angle, because those have to be equal in order to divide to become 1. Whereas anytime you see a tangent with some kind of root 3 in it, you know you're dealing with the 30, 60, 90, because you have to begin with the root 3 over 2. Okay, all important stuff. And this angle must be 135, because we know we have 45 here. Great. Let's talk about radians and move on from there. We know 360 degrees is 2 pi radians. We know 180 degrees is pi radians. We know 90 is pi over 2. We know 60 is pi over 3. And we know 30 is pi over 6, because there are 3 60s in 180. So 180 divided by 3 is 60, or 180 divided by 6 is 30. Okay, with that in mind, you should now be able to do these problems. We are given an angle and we're told sine or cosine of it, or tangent, and we have to figure out the exact value. No calculators here. This is just using unit circles. So all these angles should somehow get you to the 45, 45, 90 or 30, 60, 90 triangle. And remember, sine means find the y value, cosine means find the x value, and always consider, is it going to be negative or positive depending on its location. Let's try. Here's the first one. Check your work. Okay, try B. Here it is. 5 pi over 6 brings you to here. The 6 tells you you're dealing with 30 degrees, and 5, you moved 30 degrees 5 times, which means you moved 150. It remains 30 here. Set up your 30, 60, 90, and you find out that the cosine, the x value, is negative root 3 over 2. Check your work carefully on these. This is now really working with all the trig we've learned. Try C, now looking for the tangent of that angle. Okay, that angle is spinning negatively like this, clockwise. 6 again tells us we're doing with 30s, and we have 4 of them, so we've gone 4 slices of 30, which means we've gone 120 degrees. 60 degrees remains. We end up with this triangle. Tangent means y over x, so the y value divided by the x value, which are both negative, gives us root 3. Try this one, sine, first one. Check your work here. Try B. Check your work here. And C. Check your work here. Okay, really important you understand these ones with tangent for sure. 3 more. Try this one. Check your work. And B. There it is. Check that out. And C. And check your work there. 9 pi over 6 in this case, it means 9 times 30, because 6 again tells us we're dealing with 30 degrees, and we do 9 times 30, 270 degrees brings us all the way to here. We end up on this point here. So it's not a triangle anymore, it's just this. So y divided by x is negative 1, and the x coordinate here is 0. Negative 1 over 0 is undefined. If you punch that in your calculator using radian mode, you'll notice it will give you no answer, undefined. Okay, really important. I hope that practice of those 9 questions gave you a good start on this. Now, let's do one last thing. We did this the other day where we're looking at all the angles and changing all the angles to radians. Okay, make sure you take a look at that, pause, and complete this if you haven't done that yet. And now you're going to do what students have done for generations. You take a unit circle and you're going to put all the angles and things on there. So check this out. I'm going to help you get started on that, and your job is to fill in the rest of the circle. you need to have the full unit circle done. You can do it. So you put the angle in degrees, radians, and then the location of the point based on what we just learned.